We are going to talk about 3D topology of bifurcation during substorm onset. Our approach is as follows. Earth magnetospheric topologies can be identified using nulls or critical point, CP. A reliable numerical method entitled Geodesic Level Set method is applied to extract the global magnetospheric topologies in MHD simulation. First, we Taylor expand magnetic field around the null point, and the zeroth order term is going to be cancelled, and we also neglect the higher order term. Thus, only Jacobian matrix multiplied by the positioning vector is remained. Thus, this Jacobian matrix at the null point determines the magnetic field topologies around null point. We have a solenoidal conditions. Thus, the eigenvalue of the Jacobians lambda 1, lambda 2, lambda 3, these summations have to be 0. Following these conditions, 2 of the eigenvalues have to be minus or have to be plus. For the minus case, this is the attracting case, and for positive case, it is a repelling case. And we call this attracting case as A type, and we call this repelling case as B type. And both A type and B type can have a conjugate case. If we have a conjugate case, we call this null AS or BS or spiral. And for non-conjugate case, we just call them A, B, or radial. And the important point is each eigenvalue has eigenvectors. Those who have the same size of eigenvalues can span. So called that 2D separatics, or sometimes we refer to them as sigma surface. The magnetospheric topologies can be determined by visualizing or identifying this 2D separatrix or sigma surface. This is our visualization domain. First, we show the steady-state northward IMF topologies, and also steady-state southward IMF topologies. Then we see the change of the topology from before to after the substorm onset here. So let us first visualize steady-state northward IMF. So this is the case for Finn and Lau, and this is our visualization result. We have a CP1 and CP2, and the CP1 corresponds to B, and the CP2 corresponds to A. And this blue separatrices corresponds to sigma A, and this brown separatrices from CP1 correspond to sigma B. And for the Lau and Finn case, so sigma A spans towards south, and sigma B spans towards north. However, in the MHD simulation, in our case, this tube is bented. Both is going to bend it to form a typical shape of the magnetosphere, like this one. However, they are crossing each other. And this is also the same for steady-state southward IMF case. So we have B-type null and A-type null, and these two null spans sigma A and sigma B to form Earth magnetic field, magnetospheric separatrix. And this is a picture from the fin, Lau and fin, and actually these two separatrices bend towards the tailward to form a typical magnetospheric shape. And next we are going to show topology of the just before the onset, and at the onset and after the onset. And these blue lines and these blue surface and the pink surface are separatrix, magnetic surface from A null and B null. However, during the onset, we have more nulls to form different separatrices. And this is a cross section of the topologies just before the onset, onset, and after onset. So what we can see here is plasmoid is formed at the onset, and this plasmoid move tailward after the onset. So let us see the topology just before the onset. And we have a CP1, we have a A-type null and B-type null. However, now we have more nulls. These nulls form a complex magnetotail topologies. So the interesting point is these green lines are neutral lines. And these neutral lines are bifurcated at the tail, and half wedge-shaped magnetosphere is formed here. This means outside magnetic field is now penetrate into the dusk side of the magnetotail regions. However, dawn side of the magnetotail region is still old magnetospheres. And these complicated topologies are formed by other critical points. And now we are going to show three topologies before the onset and at the onset and after the onset by these three figures. So what we see at the onset is this half wedge type neutral line is now moved deep inside the tail regions, center of the tail regions. And what we can see here is special topologies we show later. However, the outside magnetic field is penetrated from dawn side lobe of the magnetospheres, and after magnetic field penetrate from this dawn side lobe, complete wedge type of the neutral line is completed just after onset. Now we enlarge this dawn side lobe regions. In this dawn side lobe regions, we found three nulls. BS, AS, BS is saddle connected, and this AS nulls separatrices is spirals go outside magnetosphere, and also the other side spiral go into the deep magnetotail regions. And this spiral magnetic field forms a tube, special tube, And through this tube, southward IMF can penetrate into the magnetotail regions. And this BS and AS and BS 3 saddle connections is a famous Lorenz topology. And this is known to be unstable. So what's happening at the lobe regions, dawn lobe regions, is through this special topology, unstable topologies, southward IMF is penetrate into the tail region so that this wedge-shaped neutral line or penetrated magnetic field to move inside, deep inside this tail region to form the wedge type neutral lines, so that substorm onset can start. This is our conclusions. Magnetospheric topologies during the substorm are identified and visualized. A Lorenz magnetic null tube transiently exists, and this allows the neutral line to move significantly toward the Earth. This concludes my talk.